Chalo. So we will start our class for system of particles. This is the first class of system of particles. Let's start this chapter. A very interesting chapter indeed, because till now we have studied only the physics of small particles or the point size particles, where we could neglect the dimension of the particles compared to the surroundings, right? In the first class of kinematics I have explained this to you, that whenever we apply the these concepts, we always assume that the motion of this single particle is a translational only. The particle can only move in a translational way, right? It can move in a straight line or it can move in a curved path. All of the motions are called translational motion, because it is a single particle. In laws of motion also, when you draw the free body diagram, it did not matter where you apply the force, right? Someone applies the mg from center, someone applies mg from off center, someone applies friction at the lowest point, someone applies friction from the center also, but in all of the cases you have got the correct answer. Why? Because we have also assumed the body to be point sized. We could neglect the dimension of the body, and it is very easy to understand how the point object moves. If I apply some force F on a point object, it is very sure that the object will move along the direction of force, because its acceleration is F by m, right? But it is not always the case in case of a system of particles or the practical objects that you see in our surroundings. Suppose you have a pen in your hand. Now how many particles, small particles, are there in this pen? You can see that there are millions and billions of small, infinite number of particles are actually lying inside the pen. But when you are applying some force, can you apply force simultaneously to all the particles? Externally, you can only apply force to a particular point. So what about the other points where you are not applying some external force? That is a problem, that the external force is not applied to all the particles. And how I can find the motion of all the particles if I do not know what is the forces acting on those particles? So that is why this chapter is important. From this chapter onward, in mechanics we are going to study practical questions, right? Practical questions means now we will not have a particle. Instead, we will have a rod, we will have a ball, we will have a cone, we will have a box, like this, right? Those dimensions does matter, right? And how to solve this type of questions? The first chapter is system of particles, and the next chapter we will talk about rigid body dynamics or rigid body rotational motion. So this two chapter combines. If I study these two chapters combined, then we will have a very good idea about how to deal with means extended objects, right? Let us talk about first system of particles. Any system where more than one particle is there is known as system of particles, right? It may be as given this pen. This pen is also a system of particle. If you have a bucket full of water, that is also a system of particle, right? If you have ideal gas inside a jar, that is also a system of particles, right? If you have connected two balls with a string, that is also a system of particles. So there is means any example where more than one particle is there is a system of particle. What is the difference between point object and system of particles? If I have a point object, as I have said, that if you apply a force F, then the point object will definitely move along the direction of the force, right? You can say that the acceleration of that point object is along the direction of the applied force, right? Till now we have studied about motion of particles. Here we have applied a force. The acceleration is in the same direction as that of the external force only. But what will happen if instead of a single particle we have a dumbbell shaped system of particles? Here you can assume these two balls to be point masses, right? A and B. Suppose these two are point objects and they are connected with a light rigid rod, right? The mass of the rod is negligible, and this is a system of particles where only two particles are there inside that system. Now can you see that if I apply a force F, to that system of particles like this. You can see that I have applied the force not at the exact midpoint in between A and B. I have applied the force in any arbitrary general point. Now can you say that all the particles A and B will follow this force? What from your means thinking, what you can say, that will the particles A and B both will follow the direction of the force F?
No, sir.
No,
No, sir.
definitely not. If you also try to give a force F on your pen, you can see that in any direction, in any point, if you just give a force F on that pen, you can see that the entire pen will not move in the same direction, right? It's a very common example, and I can draw a very arbitrary position of these points A and B. You can look, the points A and B, if you join, they are moving in any arbitrary way, right? You cannot say that they will move in a particular direction. Now the problem comes that how do I analyze the motion of the points A and B now? If I do not know how they are moving, then how do I find the motion of the balls A and B? How can I find where the ball A will be after a time t equal to 2 seconds? What will be the velocity of ball B after a time t equal to 5 seconds? How can I do it if I do not know how they are moving? Can you tell me why the balls A and B are not following the external force F? What is the reason behind that? A very basic question. Why the balls A and B, in case of your pen you can say, why the entire particles of that pen are not following the direction of force that you are applying on that pen?
Because we are not applying the force on the center of the mass.
I have not yet started, we don't have any idea about center of mass. But
sir, because the particles are interacting among themselves,
yes,
only the external force is not being applied on them.
Yes. If you think about the free body diagram of the ball A, you will find that on the ball A, there are some internal forces acting. Which one is providing these internal forces? This rod. This rod is providing a force on A, and similarly this rod is providing a force on B. Right? Suppose in this way, the rod is providing a force on B. And what are these forces that I have drawn? Are these forces internal or external force of the system? These forces
external.
that I have drawn? For this AB system, this force is internal force. Yes or no?
So what are
Yes.
that, sir? The
Yes.
particle forces.
Any direction. The force may be in any direction. If you have a ball connected with a rod, in which direction the rod can exert a force on that ball? Can you tell me? The answer is any arbitrary direction. If you lift that rod upward, the ball will also come upward with that rod. Yes or no? Because
Yes.
they are rigidly connected. So that is why if I do not know the exact direction of any force or any vector, I can always make this assumption that I will take two components of that vector which are mutually orthogonal to each other. Right? So in this case also I have shown that the force on A and B are like this, and these forces are absolutely internal forces. Yes or no? Now, when I am applying an external force to the system, I know what is the value and nature of that external force, whether it is changing with time, whether it is a constant, in which direction the force is applying, everything I know about that external force. But do we have any idea about that internal forces?
No, sir.
No.
No, sir.
So if I do not have any idea about internal forces, how can I find the motion of A and B? Yes, definitely if you give me some idea about internal forces, not some, the full idea of internal forces, then accurately I will be able to find the motion of A and B as we have done in last chapters. But here the problem is that we do not have any idea about internal force. Only thing we know is the external force. Then how do I find the motion of A and B? Then there is a way out. If I could find a particular point, a specific point of the system of particles, that point only follows the external force. If I can find one such point which only follows the external force, then it will be very easy to analyze the motion of that particular point. Yes or no? Again, I am saying that if you can find any point which only follows the external force, internal forces do not affect the motion of that point, will it be easy to understand the motion of that particular point? Yes or no?
Yes, sir.
Yes.
Yes, sir.
Because that is very simple. We can use Newton's laws of motion, equation for the of kinematics. I can find the motion of the particular point. But is that point available? The answer is yes. One such point is available, only one point is available for that system of particle which only follows the external force, and that point is known as center of mass. So look, center of mass is not a physical point, right? It is not that center of mass is a particle. I have not used the term particle. I have said that it is a point. Center of mass is an imaginary point which only follows the external force. So it is a definition. Why we have defined that center of mass? Because we have to find the motion of all the other particles. Now, how the motion of center of mass will help us to find the motion of A and B? Can you tell me how the motion of center of mass will help us to find the motion of A and B? Suppose in this case, this is the center of mass, right? This is the center of mass. So in all these cases, wherever the particles A and B will move, can I say that the center of mass of this combined system will always follow this straight line path?
Yes, sir.
Because
Yes.
acceleration, because center of mass will follow this equation, that acceleration of center of mass only depends on the external force. It does not depend on the internal forces. So wherever may be the other masses, the center of mass will always follow the same path. Now the question is, even if I know what is the motion of center of mass, how is it going to help to find the motion of the points A and B? Right? If you think minutely that suppose this is point A and this is point B, you will find your answer now. Suppose this is the center of mass. I know the motion of center of mass. Can you tell me how the balls A and B will move about center of mass? What type of motion?
Circular motion.
Yes. If it is a rigid body, then only. If the distance between A and B cannot change, then can I say that only possible way to move A and B about center of mass is either at rest or move in a circle?
Yes, sir.
Yes?
Yes, sir.
So suppose if I now say that A is moving in this circular path about center of mass, B is moving in this circular path about center of mass, I can find these distances, I can find the radius of that circle, So after some time t, can I find what is the position of A with respect to center of mass? Can I find position of
Yes,
A
sir.
with respect to
Yes, sir.
center of mass? And if I add with that, what is the position of center of or displacement of center of mass? Can I actually find what is displacement of point A with respect to ground?
Yes, sir.
If after some time t, I know what is the velocity of point B with respect to center of mass, then can I say that velocity of B with respect to center of mass plus in addition if I add it with velocity of C, can I find velocity of B with respect to ground? So what I can find, actually I can find the position, velocity, acceleration, whatever you ask, I can find this for the all the objects, all the points that are lying inside the center of mass.
Sir, can you repeat once?
I am saying that if you know the motion of center of mass, then other particles, if it is a rigid body, can only move around the center of mass in a circular way. There is no other way out, you can see. So if they are moving in some circle, then from circular motion I can also find what is the velocity of some point with respect to the center.
Sir, why it will move in a only circle?
If it is not moving in a circle, will that distance remain always constant? If it is a rigid body, I am talking about a rigid body. This dumbbell, I am only talking about this dumbbell. About the center of mass, can you draw any other possible ways that A and B can move? Yes or no?
Yes, sir.
Yes. So we cannot find any other possible way. Only the possible way will be a circle because the distance is always constant. Now, from center to A, from center to B, the distance is always constant. So the radius are constant in a circle. Now look, my problem actually is solved. Now you can find the velocity or acceleration or the position of any good point inside the pen that you are applying a force on it. Yes or no? But before that, what is the most important thing? The most important thing is to understand the motion of center of mass. If we can find the motion of center of mass, we can find the motion of the other particles also. So this chapter, the first chapter, system of particles, this chapter only deals with center of mass. We will understand how the center of mass behaves. How does the center of mass move in case of some external force? And in next chapter, in rigid body rotation, we will be more interested in how the other particles are moving around center of mass and how we can find the exact location, position, acceleration of any point in a rigid body. Have you got an idea about what we are going to study in these next two chapters? Yes or no?
Can you repeat what you told? Just the last sentence.
I've said that in the next two chapters we are going to study this only. That in first chapter we are going to study the motion of center of mass. That how center of mass moves with the application of external force. And in next chapter we will talk about rigid bodies, that if there is some rigid body, then how all the particles are moving around center of mass, and with respect to ground, how we can find their velocity, acceleration, position, kinetic energy, anything we can find them. Okay, so these are the two major chapters of mechanics. You can say that most of your mechanics questions will be asked from these two chapters only. And in all the other chapters, we are going to use the concepts of these two chapters mainly. Because these are more practical cases now we are going to enter. Understood? Alright.
Yes.
So I have already written these things, that when we apply external force to a system, none of the particles have acceleration along the external force. The reason behind this is internal forces along with the external force acts on each mass. Now, what is center of mass? In these cases, it is very difficult to analyze the motion of individual particles if we do not know about the acceleration of any point. But there is a way out. Out of infinite number of points, there is a particular point which has acceleration exactly in the direction of external force. This point is known as center of mass. What are the few properties of center of mass? The first property is acceleration of center of mass is F external divided by total mass of the system of particles. Number 2, acceleration of center of mass is independent of the internal forces and also the point of application of external force. So it does not matter how this center of mass moves. In this particular case, if I say that center of mass moves in this direction, even if you apply this force F on the ball B, or if someone applies the force F on ball A like this, any point you apply the force on the system, you will find that center of mass will move in the same direction, because it only depends on the force. And when you are shifting that force, actually the force is not changed. The vector is not changing if you are shifting it parallelly. Right? For a system of particles having n masses, of masses m1, m2, m3 and so on, corresponding position vectors are r1, r2, r3 and so on. Then the position vector of the center of mass is given by this formula. First one is summation of mi ri divided by summation of mi for discrete particles, and integral of dm r divided by dm for continuous particles. So suppose for center of mass, always we have a coordinate system. We have to have a coordinate system. And suppose this is a system of particles inside which there are so many particles lying. If this mass is m1, I will join it with the center and I will say that this is the position vector of m1, this is the position vector of m2, this is the position vector of m3. Right? So what is the position vector of center of mass if I have to find? Then position vector of center of mass will follow this equation: m1 r1 plus m2 r2 plus m3 r3 like this, divided by the total mass of the system. You can also break the position vector into components. For example, if I have to find the x coordinate of the center of mass, I will use this formula: summation of mi into xi divided by summation of mi. Similarly, for y coordinate, I will use this mi into yi divided by summation of mi. Right? What is yi? Yi is the y coordinate of the particle m. Right? Mi. So the point coordinate of m1 is x1, y1, m2 is x2, y2, like this. But this formula is only applicable when the system is discrete. That means you can identify which mass is m1 and which mass is m2. But instead, if I have this system, suppose I have a continuous object like this, can you identify where is m1 and where is m2? No.
No, sir.
I cannot identify which one is M1, M2. So what I will do, I will take a small dm mass anywhere, and I will find the position vector of dm mass. Then I will integrate it, because I cannot add all the dm masses multiplied with their position vectors. Right? Why? Because there are an infinite number of dm masses. How many I will add up? Right? So in that case, the position vector, the x coordinate will be integral of dm into x divided by integral of dm, and y coordinate is integral of dm into y divided by integral of dm. Right? Instead of summation sign, I have now used the integration sign. Similarly, for z-axis, if it is a 3D object, you can also use the z coordinate of the center of mass. And for regular bodies with uniform mass density, for example, a solid ball, a cone, a square plate, right? For all these bodies, you can use their geometrical centers to be the center of mass. Right? If you know the geometrical center, then you do not have to actually calculate the center of mass. You can say that their geometrical center is nothing but their center of mass.
Sir,
Bolo?
so can we use this even when the shape is any arbitrary shape?
Which formula? The formula number 3, that I have written, is useful for any arbitrary shape, But for geometrical center, you should know the geometrical center. If I give you any arbitrary shape, can you find its geometrical center? No. Right? So in that case, it is better to do this integration. Is there any doubt regarding this slide?
No, sir.
Well, now we'll try to calculate the center of mass. In next few questions, we'll take up few examples of discrete and continuous both, and we'll try to locate the center of mass.
Is centroid.
Continuous center of mass of a triangle, yes, centroid. For a triangle, it is centroid.
For a triangular plate.
Yes, also for a triangular plate, you can say it's a centroid.
I mean, for a triangular wire structure, I mean, if I just take the perimeter, then it will not be the centroid.
If you take if it is of uniform mass density, then you can you can take it as a centroid also.
No, sir. If it is of uniform mass density and I am just taking the perimeter, it is made of wire, maybe. Then the center of mass will not be the centroid.
It is made of wire.
Yes.
Alright, then you have to calculate it.
Yes, sir.
Okay. So let us solve few questions, then the idea will be more clear to us. Suppose 5 point objects are placed at the 5 corners of this pyramid. The base is a square and all the side lengths are A. Of this pyramid, all the side lengths are A. Masses are given in your question. Can you locate the XYZ coordinate of center of mass? I'll first write down the coordinates of the points. Can I say the coordinate of C is A by 2, A by 2, 0. Coordinate of B is A by 2, minus A by 2, 0. Coordinate of A is minus A by 2, minus A by 2, 0. And D is minus A by 2, plus A by 2, 0. Masses are M3M, 2M and 2M. Coordinate of E, mass is 2M, coordinate of E is 0, 0, A by root 2. Check first about the coordinates I have written. Have you also found the same
Yes, sir.
coordinates?
Yes,
Yes, sir. These only.
Yes.
sir.
that one.
Then the x coordinate of center of mass is summation of mi(xi) divided by summation of mi. So I can make it m into minus a by 2 plus 3m into plus a by 2 plus 2m into a by 2 and plus 2m into minus a by 2 and plus 2m into 0 for the particle at E. And total I will divide it by 10m. What it is it a by 10? If you calculate it, 3m minus
sir.
m 2m into a by 2 is m into a by 10m is a by 10. Similarly
Now the
for
z coordinate is coming a by root 2.
z coordinate, if this side is a, this side is a by root 2, it is perpendicular. So what should be the height?
A by root 2.
A by root 2. Y coordinate I will also follow the same formula. So it is m into minus a by 2 plus 3m into minus a by 2 plus 2m into a by 2 plus 2m into a by 2 and plus 2m into 0 divided by the total mass is 10m, and you will find it to be 0. Right? They will get cancelled out. And the z coordinate is, all the other terms are 0. Instead the last term, which is 2m into a by root 2 divided by the 10m. So that is equal to,
am by 5 root 2.
yes, root 2 means a by 5 root 2, you can say. Have you got this one?
Yes, sir.
Yes. Look, one more thing to observe from this question. If you cut this pyramid by this xz plane, if you cut this by this xz plane, right, this xz plane, suppose you have cut this pyramid by this xz plane. So what is the mass on the left side of this xz plane? Is it 4m? 3m plus m?
5m.
And what is the mass on the right side of this xz plane?
5m.
5 or 4?
Sir, half of E.
The 4m.
4m. Right?
And
E lies on xz plane, so I will not take the mass E. E is a point object, right? So it lies on xz plane.
Sir,
Yes.
sir, after finding the z coordinate of C, what did you tell about this figure?
I have said that if I cut this pyramid by xz plane, if I cut this pyramid along a plane which is xz plane, then
Yes.
what is the mass that is left on the xz plane? It is 4m. And can you find a similar mass lying on the right side of the xz plane?
Yes.
And are both the masses symmetric? That means both the masses are placed at a same distance from the xz plane.
Yes.
So if this system is symmetric about xz plane, can I say that its y coordinate is 0? That is why I have got it 0 by calculation also,
Yes, sir.
right? So from this we can use the concept of symmetric system. If a system is symmetric about any plane or about any axis, then perpendicular to this plane or axis, the center of mass coordinate will be 0. Understood this?
Yes, sir.
So that means by finding the total mass count in the about a plane, it's both right side and left side. We can use the sectional formula to find the
Yes. For the
coordinate of
symmetry, you
the
can use the
center of mass.
symmetry whether it is 0 or not, right? But I cannot find the exact value if it is not 0. Then you have to use that mathematical formula.
People only if it is equal on both sides and it comes 0.
Yes. Okay. And you should remember also one thing, that center of mass always divides the line joining 2 points in their inverse ratio. For example, if there is a point mass and there is another point mass, suppose there is one point mass here and there is another point mass that is here, right? If this mass is small m, this is capital M, and if this length is L, you have to remember that the center of mass will always lie towards the heavier mass, and the line is divided in a inverse ratio. That means this part will be M and this part will be small m. So the length will be M into L by M plus M, and this length will be capital M into L by M plus M. How can I prove it? If you take this to be your x-axis, this is to be origin, then what is the center of mass x coordinate? It is the small m into 0 plus capital M into L divided by total mass. Yes or no? You can find that this is the distance we have got. Right? So center of mass always divides this line joining the two masses in their inverse ratio. That thing also you should remember.
So that only I told about the section formula we can use.
Yes, that section formula you can use. But it is only for two objects, 2 point masses. If there are more than 2 masses, then you have to individually apply it for every pair. Alright.
So if you do by the total count of masses.
No, if they are in the at the same distance apart, then only you can do it.
Yes, sir. I'm telling about the same distance.
Yes.
In this case, they are same distance only.
Yes. In that case, you can do it. Now it is a continuous body. I have taken a portion of an circular ring. The portion, the arc of that circular ring makes an angle alpha at the center and the radius is r. Can you calculate the distance of the center of mass from the center of the ring? If this is the center of the ring, if O is the center of the ring, this is the radius r, right? These two lines are not actually physically present. I have drawn them to show the angle. This angle is alpha. Can you tell me from what is the distance of the center of mass from this point O? Can you try to calculate it? Remember, it is a continuous object, so you have to integrate. You cannot add. Suppose this is the arc. I will draw this y and x axis like this. Why I will draw it? Because I want to exploit the symmetry. Here this diagram, this configuration is symmetric about y-axis. So I can very easily say that what is the x-coordinate of center of mass. Can you tell me what is x-coordinate of center of mass here?
0.
0. Because it is symmetric about y-axis. So what I will now do, I will take a small element. I will take a small element like this. At angle theta from this vertical line. Suppose this angle is theta and I have taken a small angle t theta. So the element that is trapped inside this small length is dm. And what is the length of that small segment? Can you tell me? RD theta. And if I say that lambda is the mass per unit length, lambda is mass per unit length of that ring, which is a constant. So I can find that dm is equal to lambda RD theta. Now I will use the formula for y coordinate. It is integral of dm into y divided by integral of dm. Now what is y here? Y is the y coordinate of that point mass. What is y coordinate of this point mass? I can find it to be r cos theta, because this is r, this is 90 degree, r cos theta. So now my integration is ready. I can do it. It's lambda into RD theta into r cos theta. And what will be the denominator? Can you tell me? Total mass?
R into lambda.
R alpha into lambda. And where will be the limits vary from? Lower to upper limit, what will be there?
So minus alpha by 2 to plus alpha by 2.
Minus alpha by 2 plus alpha by 2.
Good. Because here theta is 0. So in this direction theta is plus alpha by 2. And this direction theta is minus alpha by 2. So if you do this integration from minus to plus alpha by 2, you will find that lambda will get cancel out. So r by alpha into 2 sine alpha by 2. Right. So that is the y coordinate of center of mass for any segment of the circular arc. Right. Now if I take this circular segment, there is a semicircular part. Right. If it is a semicircular part, then where will the center of mass lie? From its center, where the center of mass will lie?
On y-axis.
OC will be how much?
2r by pi.
Yes, sir. 2r by pi.
2r by pi. Right? You should remember this value. This value you should remember, right? This value is not very important to remember, but this one is important. For a semicircular ring, it is 2r by pi. And suppose if I cut this semicircular ring, into two halves, such that this segment is also r by 2 and this length is also r by 2. Can you tell me which one will be heavier? The upper segment or the lower segment? Which one will be heavier?
Lower segment.
So lower segment.
Lower segment, why?
So because the center of mass lies within it.
Because the center of mass lies here. R by pi by 2. R by pi by 2.
Your question, my connection cut.
I've said that if I cut that semicircular ring by 2 equal halves, equal means from lower segment it is also r by 2 and this segment it is also r by 2. Right? I have cut it horizontal in this horizontal line. Then which one will be heavier, the upper segment or this lower segment?
So lower one.
R by pi by 2 is greater than r by 2 or not? or less than pi?
Yes, sir. Yes, sir. Greater than.
Greater than.
Greater than. So if it is greater than, then where will the center of mass lie?
Upper.
Upper segment. So upper segment will be heavier. Because center of mass always lie towards the heavier segment.
Okay.
Understood? Center of mass actually lies here. This is 2r by pi. Greater than r by 2. Right?
So actually I did not get the point.
As I have said that if there are two masses, one is heavier mass, one is this small m, one is capital M. Right? So where the center of mass will lie? Towards the heavier mass or lighter mass?
So it was the heavier mass.
Yes. Now this ring, this semicircular ring consists of two parts. One is this upper segment and lower segment. So center of mass will lie towards the heavier segment. So if I cut it from this r by 2, this two equal distance r by 2, where the center of mass lies? Above r by 2. So what is the heavier segment? This one is the heavier segment. Upper one is the heavier segment than the lower one.
Okay, fair.
Now, if this is xy plane, can you only find the xy coordinate of this quadrant of this ring? Radius r.
2r by pi x and y also 2r by pi. Same.
Yes, they will be same.
Yes, sir.
Because if you draw a line like this, then center of mass will lie here. And what is the distance OC? If you find the distance OC, then I will just put the formula here. It is 2r by alpha. What is alpha here?
Pi by 2.
Pi by 2 into sine pi by 4. So that is 4r by pi into 1 by root 2. Right? 2 root 2 r by pi. That is the distance OC. But this angle is 45 degree. So what is the xy coordinate? Cos 45 degree, sin 45 degree. So it is 2r by pi, 2r by pi. With this similar concept, can you find the center of mass of a section of circular disc? So this is a section of circular disc that I have drawn here. This is a disc. Can you find the location of center of mass from this center of, if the radius is r? Try to calculate it in a very similar way that you have done the earlier one. Okay, how we can solve it?
Sir,
Bolo?
sir, is the answer 4r by 3 alpha into sin alpha by 2?
Yes, yes, good.
So we will take a small ring, a part of a ring.
Yes. So, suppose this is the disc. Again, I can take this my y-axis, this my x-axis. So that x coordinate I don't have to calculate, it will be readily 0. X coordinate is 0. Y coordinate I have to calculate only. Now, what type of elements I will take so that after integration I will find the disk.
So one for the radius and one for the theta. Two parameters we have to take.
But I can only take this ring.
Yes. Yes, sir.
Right? At a radius small r, I will take a small ring of thickness dr. Look, this ring, if I integrate this type of small rings, I will eventually find the disk. So first we have to think about the ring, then we will only integrate. For that small ring, what is the mass of that small ring that I have to find? First, can you tell me what is the area of that ring? Area of that ring. If you take this ring outside and unfold it, you stretch that ring, can you find a rectangular strip like this? What is the length of that rectangular strip? Is it R alpha? And the thickness of that rectangular strip is dr?
dr.
So what is the area of that ring? Is it only R alpha dr? Yes or no? So what is mass of the ring?
Sir, R alpha dr lambda.
Into sigma, let us assume. What is sigma? Sigma I have assumed to be mass per unit area. Here what I will take, mass per unit area or mass per unit length? Mass per unit area.
Per unit area.
Yes. So I know what is the dm and what is the y coordinate of the center of mass of the ring. Can you tell me what is y coordinate of the center of mass of the ring?
2 smaller by alpha sin alpha.
2 small r by alpha into sin alpha by 2. We have got this formula just now. Then I can integrate it to find the y coordinate of center of mass is integral of dm into y divided by dm. Sigma r dr alpha into y is 2r by alpha sin alpha by 2. I am just putting the value. What is the integration dm? Even if we do not integrate, I can find it. Is it sigma multiplied by pi r square is the total area of that disk
By 2 alpha.
by 2 pi into alpha, can I take?
Yes.
And the only variable in this integration is what?
I.
R
R.
dr.
So I can integrate it from 0 to capital R. Now if you do this integration, it is r square dr. You can find r dr. R square dr means r cube by 3. So you will find this answer. You can do it. It is 4r by 3 alpha into sin alpha by 2.
Sir,
Bolo.
so we could also take an arbitrary element dm at distance r from the radius and with thickness dr and subtends an angle of d theta and then double integrate it.
Yes, also you can do that double integration. But as we know the value of that ring, we can always use this. Okay. All right.
Okay, sir.
Also, I think you can take this type of element here. I have not tried it, but I think it will also work. If you take these triangular segments, suppose this is the disk, xy axis, if I take a triangular segment like this, can you see this is a triangular segment? What is the center of mass of the triangle? Can you tell me what is center of mass of this triangle? Where does it lie?
Centroid.
At a distance h by 3 from the base? Yes or no? Do you know that? From the base of a triangle, the center of mass lie at a height h by 3. So if I take this center of mass, which lie at 2r by 3, right? If this angle is theta, then the y coordinate of this center of mass will be 2r by 3 cos theta. And I can find what is dm. What is dm here? What is the area of this triangle? Can I say it is half r square d theta?
Yes, sir.
Yes, sir.
Half into base is r d theta into height is r into sigma, right? So try to do it. I do not know, I've not tried it, but again it should come the same value, r square by 2 sigma d theta multiplied by 2r by 3 cos theta divided by the total mass we have calculated, sigma r square alpha by 2. Look, r square by 2 will get cancelled out, sigma will get cancelled out. So 2r by 3 alpha, 2r by 3 alpha will be there, and integration will be cos theta d theta from minus alpha by 2 to plus alpha by 2. Is it 2 sin alpha by 2?
Yes, sir.
Yes, so you will get the same answer. 4r by 3 alpha into sin alpha by 2. So you can take different elements, right? Whichever you think it's better, you can take it. But whatever element you take, you should know the center of mass of that element, right? Then you can use this formula. Is this alright for us?
Yes, sir.
Can you find the center of mass of a hollow hemisphere? Hollow hemisphere, you take any hollow hemisphere. This is the hollow hemisphere. This is the center of the hollow hemisphere. Can we find the center of mass of this hollow hemisphere from the center O? If this is the center of mass, what is the distance OC?
Yes, sir. R by 2.
Try to calculate it.
Yes, sir. R by 2.
Yes. So here let us take this small segment lying in between theta and d theta. So this angle is theta and this small angle is d theta. Can you assume a small ring lying here?
Yes, sir.
A small ring that lying over the surface of that hemisphere like this. The radius of that small ring is r. The center of mass of that ring is definitely at the center. So what is the area of that ring? Area of that ring. Again you use the same concept. If you take this ring outside and unfold it, you will find a rectangle. So what is the area of that rectangular strip? Can you tell me? What is the length of that rectangular strip?
2 pi r
cos theta.
Yes. And what is the width of that rectangular strip?
d theta.
Yeah.
R d theta. And what is small r? Small r is capital R sine theta. So I can say that the mass of the ring dm is equal to sigma into 2 pi r sine theta into r d theta. Right? So mass of the ring is this one. And what is the y coordinate of center of mass of the ring? Is it r cos theta? Yes or no? This much distance is r cos theta. So what is the y coordinate of center of mass? I will integrate dmy divided by dm. Integral of sigma 2 pi r square sine theta cos theta d theta r cube divided by the total mass is sigma multiplied by 2 pi r square. Have I done it right? Check once.
Yes, sir.
Can you tell me the limits of the integration?
0 to pi by 2.
0 to pi by 2, yes. Yes, it is not minus pi by 2 to plus pi by 2 because the ring also lies on this side. Right?
Yes, sir.
So it will come from 0 to pi by 2. Sigma 2 pi will get cancelled out, r square r cube, only r will there. R by 2 into sine 2 theta d theta, can I say that? So what is sine 2 theta d theta? Is it half into minus cos 2 theta? Now what is minus cos pi? Cos pi is 1, so minus cos pi is plus 1. Minus of minus means plus, cos of 0 is plus 1. So this is 2, 2.5 will get cancelled out. So my answer will come to be r by 2. Yes or no?